So in this session, we will try to write a code for a single linked list. So yes, in a single linked list, we have an nodes. Okay, so we have a node. So at first, we should create a node, and then followed by at first we will create a node, and then we will ask a user whether do you want to add more number of nodes or not. If they say yes, once again we will create another node. And then once you create a node, what do you do? Before creating node, at first we should allocate a memory space to them. Suppose if you are coming to my room, okay, so what do I do? My room, you might be the node, but my room is memory. My room is a large amount of memory. But in the large amount of memory, I should allocate a memory space for you. Then only you can come and stay over there. Okay, in my room already there are 14 people, 15 people are there. Then if you come over there, then you won't find space over there, right? So whichever node comes in, whichever people comes into my room, at first I should know that whether I can allocate memory space or not. So I will allocate memory space for them, and then I'll ask them to stay in my room. Likewise, at first while creating a node, I will allocate a memory space for that node, and then in the memory space the node will be get stored, and then inside the node I have two fields over there. One is called data, another is called pointer. In the data I will store the new data. In the pointer I will link to the next node of the linked list. Okay, this is the overall idea of an programming of for a single linked list. So at first we will create a node. At first we will create a node, and then allocate memory space for the node. And then once allocate memory space, get data, and then provide the link in the linked list. So now what happens over here? I have created a node. Then once I create the node, then I should create this link. I should create this link. Once I create this link only, it will be get stored in the single linked list. So this is algorithm for your single linked list. At first, we'll create a node. This node will be gets created, and then we'll allocate memory space inside. Dynamically, we'll allocate a memory space inside a inside a memory, and then we will get the data from the user, and then we will provide this link. The arrow mark is there, right? Then we will provide this link in the linked list. Okay, so this is the flow of your program. Okay, so now we start to write a program. So now, at first we should create a node, right? So we people know that already in the previous session we have seen how to create a node. So now here, so struct node. So this is the corresponding and data type. Since we have an inside the node, we have two data fields. One is called an integer and other is called an pointer. We can create our own data type that is called struct. And then here we have an node. So inside the node we have an and data, and then here this pointer is going to hold some another node which is a type of a structure, so that's why I'm giving struct node and corresponding pointer. Okay, so now we have created a node. Okay, so once you created a node, so the node is the first step is done. The first creation of node is done. So now here in the linked list, what are the pointers are required? So I need a head pointer. So one is required, head is required, and then I'm going to have one more variable or one more pointer called temporary. Why? What's the reason? Because since head cannot be changed, head will be always points to the first node. So head cannot be changed. So in the temp, I will store the new node address. New node address. Suppose for example, the second node is added in the linked list. So I will store the address of a new node into the temporary memory, temporary pointer. Okay. So once the third node is created, then I'll store the new node address in the temporary pointer. Okay. So now here I need two pointers, and one is called an head pointer. Another one is temp, and then here we are creating a new nodes. Okay, so that new node will be having one address, will be having one address. So that's a pointer, that's a pointer. So I need one more pointer called an a new node. Understood? So I need three pointers. Pointer, the head, temp, and new node. So now the first step is done. Creation of node is done, and then we have declared and corresponding all the pointers. So now directly we can go to our programming. Okay. So initially, there is no nodes, there is no nodes in the linked list. So at first the head will be equal to zero. Head will be equal to zero. Am I right? Because there is no node in the linked list, so head will be equal to null. Head will be equal to null. Understood? So now we'll go for a next step. So now I am going to create a new node. So here the new node, our node will allocate a memory space dynamically. Okay. So now here, what happens here is, so for example, it allocates an memory of an corresponding one struct node. I will show it over here. How do I do this? So now here, at first, I'll be having a size of my structure node. So then the node I'll be having in two fields. One is called data and the other one is called pointer. So for the size, I should allocate a memory space. I should allocate a memory space. So now here, size of, so here our node is called a struct node. Okay, our node is called struct node. So for this only, I'm going to allocate a memory space. So this for this size, I should allocate a memory space, right? So size of struct node. So here memory allocation. Okay, we are going to perform dynamic memory allocation. So memory allocation malloc. So I'm going to allocate memory space for this struct node type. Okay. So now here in the new node, we store the address of the corresponding the structure node. Okay. So here I'll be giving an struct node. Yeah. So this is how we can allocate a memory space for a new node. This is very, very important line because throughout this linked list, wherever we are creating a node, we will use this same line. Okay. So size of an struct node. Okay, in the struct node we have two fields. One is called data, other one is called pointer. So size of a struct node, and to allocate memory space, memory allocation for this struct node, which going to return a pointer, which going to return a pointer. So we are going to typecast. Okay, so we are going to cast into a struct node pointer. So this is a new node address. Okay, so in the new node, I'll be having an address. Okay, in the NN, I'll be having an address of the new node. So now once a new node is created, memory allocation is done. Then next step is what do we do in algorithm? we will get data from the user. We will get the data from the user. So get data from the user. So where do we store the data over here? In the new node field, in the data in the field called data, we will store the data, the corresponding input data. So in the new node, what is the corresponding data field name? Data field, DATA. So understood? So now a new node is created. So a new node, for example, we will take this itself. So a new node is created. So in the head, we didn't give anything. So let it be blank. A new node is created. This is a new node is created. A new node is created. In the place of new node data field, we have stored the corresponding and data. Okay. And then the next line going to be in the new node of pointer. In the new node of pointer. So okay, since it is a single node, I don't know whether I will store the next node or not. Okay. But at present is going to be null. At present is going to be null. Okay. In the new node pointer field, it will be equal to null. It will be equal to null. So here I'll be storing a null over here. So now a node is created. A node is created. Okay, then what do we do? Once node is created, then we should provide the link in the linked list. We should provide the link in the linked list. So now at first, what do we do over here? I'll be having an head over here. I'll copy this. So at first I'll be giving an head value. Okay, so at first I will check that whether head is 0 or not, because sometimes I might add an last node, or I might add a second node or fifth node or seventh node, or I might do the first node. Okay, so at first I will check for whether my head is equal to 0 or not. If head is equal to 0, if head is equal to 0, then what do I do? The new node address, in the NN, which stores the address of the NN stores the address of the new node, right? So the corresponding new node address is assigned to the head. So now what happens over here? Head becomes 1000. Head becomes 1000. So since head becomes 1000, what happens over here? The link is created. The link is created from the head to the new node. The link is created from the head to the new node. Okay, so now for example, if you repeat the same step and then we have gotten another new node. Okay, another new node. We have got another new node. Okay, so there is something called 9. So now here in this time, so now the second node should be added in the linked list, right? So now at the second node, whether the head is equal to 0, no, because already head having the value called 1000. Okay, so now what do we do? I'll add one more case called an else. So now what should I change over here? In place of here, I should add a new node address. New node address, that is something called 2000. That is something called 2000. So once I add 2000, then the corresponding the link will be created from the second node to first node to the second node. First node to the second node. So now here, so the first node to second node should be link should be created. So now here, how can I change this place? So head of pointer, head of pointer. Okay. So now here, if we observe over here, head is 1000. 1000 of pointer. 1000 of pointer is this place, 2000. Okay, so in this place, the head of pointer will be changed to the new node. For example, I'm going to add one more node, the third node. That time, I cannot change because head will be having only 1000. That will point towards only the first node. But as I keep on adding to one more node or one more node, that time the head of next cannot be changed. Okay, for example, here is if I'll say the scenario over here. In this scenario, if we given as a head of pointer is equal to new node. Okay. So now what's a head? Head is 1000. This place, the first node, 1000. 1000th, in the 1000 node, pointer position, pointer field. In the pointer field, I'll show the 2000 node, 2000 as a address. So the now link is created. Link is created. So now let me save another scenario. So now in this scenario, will this work? Will this program work? Let's see. So now head is 0 or not? Head is not 0. Head is not 0 because already we have two nodes are there. So the if case condition disabled. So now we'll go for else case. In the else case, what happens over here? We have given head pointer position. What's head? Head is 1000. 1000th pointer position is already second node address has been stored over here. But here, where should we change over here? We should change the address of the second node pointer position. Second node pointer position, pointer field position. Okay, so that's why this program will not work. So now that's why we require a temporary pointer over here. That's the purpose of this temporary pointer, TMP. So now I'm going to assign a same head to the temp. So head also 1000, temp also 1000. So now here temp of pointer, temp of pointer. So 1000 of pointer is going to be new node address. So now after every change of an corresponding uh, address, I will update the temp pointer to the new node address. New node address. So now here, what happens over here? At first, I have added this node 7 and 2000. Okay, so temp of pointer becomes 2000 and then the temp becomes an 2000. Okay, so now the new node is created. New node is created. So the if case will not satisfy. If case will not work. It will come to the else case. So now temp value is 2000. So it will comes over here, the second node, 2000 of pointer position. So what's the new node address is going to be the 3000. 3000. So the link is created. The link is created. The link is created. So once I created a link, I will update the temporary pointer to the new node address that is called an 3000. That is called something called 3000. That's a that's a new node address. Okay. So likewise, we can keep on adding a new node. But we should ask the user whether they want a new node or not, whether they want a new node or not. So through here, what happens over here? It will create a new node memory space, and then it will get a data, and then it will allocate a node in the linked list. So we should ask a user do they want to add a new node in the linked list or not. So now here I will do it. new node is required or not. So you can ask the user to say an yes or no. You can ask the user the an yes or no. So you can scan the corresponding user. Scan the user choice. So now here I'm going to make a change in the program. So if choice is yes, if choice is yes, if choice is 1, so I'm going to add a loop over here while choice. If choice is true, if choice is true, then I'll go inside the loop and then I will create a memory space for this new node and then I'll be keep on doing. Okay. So here I will add in one more parenthesis to close this while loop. And then this printf and then this. So is it clear? So now you can see that at first what we have done. So at first we have created a node and then followed by we have created some 3 pointers for our accessibility inside the linked list. And then initially I have declared a head as a null and then we will ask the user whether they want to add a new node or not. If yes, choice is yes. If choice is equal to 1, then I'll go and allocate a memory space for the new node, and then I will get the data from the user, and then the new node pointer will be equal to null. Okay. So now at first I'll check for if my head is equal to 0 or not. So if it's a first node, then I will assign the new node address to the head, and then head will be equal to temp equal to new node address. Else, I will create a link to the second node and or third node or fourth node through the temporary pointer. So then I'll be keep on asking a user that whether they want yes or whether they want to add a new node or not. So this is how we have created a linked list. So for example, if I want to print the all the data which we have in a linked list, then how do we do? So we should travel from head node onwards. We should travel from head node onwards. So here at first I'll giving as a temp is equal to head, temp is equal to head, while so until what point I'll be keep on traveling? Until temp will be equal to 0, I'll be keep on traversing. I'll be keep on traversing. So I'll be keep on checking the whether temp is equal to 0 or not. So if it's not equal to 0, I'll be keep on processing. I'll be keep on processing. So for traversal purpose, we are doing this. So at first temp is equal to head, and then while temp is not equal to 0, I'll be keep on traversing. So what should I do it over here? I will print the temp of data. Yeah, fine. So temp of data means what does it mean? Here temp is equal to head. So head is 1000. 1000th of data is 7. So 7 will be gets printed. 7 will be gets printed. And then I should update the temp. I should update the temp. Temp is equal to temp of pointer. So now what's the temp here? Temp is 1000. 1000th of pointer field is 2000. So temp will be and updated to the new value called 2000. New value called 2000. And then I can count the number of data. I can count the number of data. So I will declare one more variable called count. and then I will add the count as plus plus. So now what happens over here? Temp will be equal to 2000. So then temp is not equal to 0. So once again, the 9 will be gets printed, and then temp will be changed to the 3000. Okay, and then temp is not equal to 0. So the temp 3000 data is 9. Okay, so sorry. So let me take some other data 8. So 8 will be gets printed, and then temp value is assigned to the null 0. So this while loop gets failed. Once while loop gets failed, we have printed all the data which we have in a linked list, and then we should print a number of count also in the output side. So I will add in one more statement, print of count is equal to count. So we have printed a corresponding all the data, and then we have counted the number of data in the linked list, and then we have printed in the output side. So this is operation of traversal. So in today's session, we have seen about implementation of linked list. So in the implementation of linked list, what algorithm we have taken? At first, we should create a node, and then we'll allocate memory space. We will get a data from the user, and then we should provide the link in the linked list. This is the algorithm we have taken. So at first, we have created a node by using an structure data types. And since why we have used structure? Because since we are having in different types of data fields, integer and then pointer, we have taken a structure to create a own data type, and then we have declared some 3 pointers as a head, temp, and new node, and then initially the head is 0, and then we will allocate a memory space for the new node and get a data from the user, and then the pointer will be 0. So once a new node is created, we should create a link between the head and to the first node, and first node to the second node, second to third, and keep on going. So by using if else conditions, we have created those link, and then we will ask the user whether they want to continue or not for a new node. And then for traversal operation, we need to print all the data which we have in the linked list. So we have assigned temp is equal to here, and then we keep on traversing for the temp of data it is printed, and temp of pointer data pointer address will be keep on changing to the temp. So until temp is not equal to temp is equal to 0, it will be keep on printing the data. So once it is done, we will print the number of values in the linked list. This is the implementation of a single linked list. So for implementation of single linked list, is this a program? For circular linked list, the same program, but there is only one change in this program. Okay, there is only one change in the program. So now what happens over here? So for here, what should I do to over here? The circular linked list, this last node will come back to the first node. Okay, the last node should store the address of an first node address. First node address. So now here, I am going to add one more line, temp of pointer. Temp of pointer. What happens over here? Temp is 3000. So 3000th pointer field, we should have the head value. We should have the head value. What's head value? Head value stores the first node address. First node address. So here I will store the head node address. So now what happens over here? The link is created from the last node to the first node. It's a circular linked list. So the only one line. If we add this one line, then it becomes circular linked list. Circular linked list. So without this line, we'll be having a normal single linked list. That's the only difference between a single linked list and circular linked list implementation. The remaining everything is going to be same. Okay. Thank you.